Okay, so hi. So this is gonna be the video for exam 2 for question 24.64. So I'll just go ahead and start off by reading it. It says a parallel plate capacitor is made from two plates on 12 centimeters on each side and 4.50 millimeters apart. Half of the space between these plates contains only air, but the other half is filled with plexiglass of dielectric constant 3.40. And then it says an 18-volt battery is connected across the plates. So then the question is asking A, what is the capacitance of this combination? Hint, can you think of this capacitor as equivalent to two capacitors in parallel? And then B, how much energy is stored in the capacitor? If we remove the plexiglass but change nothing else, how much energy will be stored in the capacitor? So let's go ahead and start off with A. We can very much see that this is kind of like a it's those problems where you basically add C1 and C2 and then you get the total. So we'll go ahead and start off there. So this is going to be A. Pardon me if it's messy. It's just that this is what I have to work with. So just kind of like as an explanation for capacitance, it's basically it's Q over the change in V, right? Delta volts. But obviously we have to modify the equation a little bit because of the information given. So really what we're working with here is C is equal to epsilon zero, right? And then for C1, actually, let me go ahead and put this here, we're going to use K. The reason that we're going to use K is because the plexiglass portion has a dielectric constant of 3.40. So we do have to account for that when we are calculating for the capacitance of each part, right? So then we're going to go ahead and just do the equation we know. We're going to continue epsilon 0 K, and then in parentheses A divided by 2, right? And then over B, okay? And then, so for that first part, for which is really like the plexiglass portion, that is going to be equal to 8.854 times 10 to the negative 12. Let's see here. So we're going to do that, and then we're just going to go ahead and put it in parentheses. Then you just multiply by the k, which was given. That was 3.40, 3.40. And then for the a divided by 2, now we have to keep in mind that it did specify that it's made from two plates, 12 centimeters, right? But since it specifies that it's a parallel plate capacitor that's made from two plates that are both 12 centimeters on each side, we have to square that. So really that's going to be 144 centimeters if you think about it, but obviously we're going to, do the conversion. So then that is going to be equal to 0.0144 because that's how much that is squared, and then divided by 2. Okay, so then we do all of that, and we just get the D, which again was given, which was 4.50 millimeters. We're just going to go ahead and put it in scientific notation since this is in scientific notation as well, and it just kind of makes things easier on the calculator. So we're going to go ahead and do that. I apologize for the bad handwriting. Now we're going to do times 10 to the negative third. Okay, and then let me just go ahead and move my camera here very briefly. And so there we're going to get 4.81 times 10 to the negative 11, right? So that's the number that we're going to get for that. For B, it's going to be something of the same process, but now we're doing it for the air portion. So then we're going to put, oh, excuse me, actually, well, B is actually the calculation for how much energy is stored in the capacitor. What I meant was for the second part of this problem, for the second part of A. So we're technically not done with A. I'm going to go ahead and delete this and continue with C2. Let's go ahead and do that. Oh, okay. There you go. Let's go ahead and up the thickness a little bit so that it's easier to see. So then we got C2, and we're essentially going to do the same thing as before. The only thing that we're not going to do is put the K because there's no dielectric constant for the air portion because the problem did not give that to us. So we're going to go ahead and go like that and then do D. So it's going to be the same constant as before, 8.854. 8.854 times 10 to the 12. And then we are going to go ahead and put that right there. Oh, excuse me. Let me just go ahead and delete that. We're just going to go ahead and continue with the problem. Let's go ahead and just for simplicity's sake, we'll go ahead and do it just like this. 10 to the negative third, right? And then we're going to put the same distance. Now, bear in mind that this value right here is basically just this in scientific notation form. That's not a new value. That wasn't a new value given to us. That's basically this term right here just condensed as scientific notation, just for reference. All right. Once we do that, then we are going to get a capacitance of 1.41 approximately. You do have to bear in mind that this is 1.42, right? So we're going to go ahead and do that and then times 10 to the negative 11. So we have both answers. Now to get the sum, we just add them. So we are going to add C1 plus C2. I'm not going to rewrite the terms only because that would take me a little bit to do. But if you add this right here, this value in the box, and then this value right here in the box, what you're going to get is approximately 6.23 times 10 to the negative 11. And so then that is the answer for part A, right there. That is the answer for part A. It's just a matter of calculating the capacitance of each part, the plexiglass and the air, and then adding them together. Now, let's go ahead and just delete this very briefly. I'll just go ahead and go like that and delete. Actually, I think it would help. Oh, no. Let me just go ahead and delete like this. Let me go ahead and pause the recording actually, just while I delete. Okay, so we're here with a freshly clean slate. So now we just have to move on to part B and part C. Part B and part C are both relatively easy. You just have to pay attention to what it is they're asking you. So for part B, again, they're asking you how much energy is stored in the capacitor. So it's literally just a matter of using the equation we already know. So that's going to be E is equal to 1/2 of CE, which we calculated previously, right, times V squared. Okay, so then as you can imagine, that's going to then equal 1/2 times 6.23 times 10 to the negative 11. Then we're going to multiply that by 18 squared because that is the V, right? And that's what the problem dictates. So you get that, and then you are going to be receiving an answer that I'm going to put in full just because it is sort of like that number right there I feel like is significant. So we're going to go ahead and put this much significant figures and then put times 10 to the 8th joules, okay? So then that is how much energy is stored in the capacitor. Now for C, and then let's see. So for C, just to review, we are asking if we remove the plexiglass, then how much energy is stored in the capacitor. We have to calculate again. Now we're going to do essentially the same problem that we did, or excuse me, the same equation that we did before with the C is equal to epsilon and all that good stuff, except since we no longer have to divide the area of the entire system down the middle, we're not doing A divided by 2, we're just doing A. So because of that, then we're really only doing the 12 squared number, but obviously like converted, so it's going to come out as a decimal. So that's going to be epsilon times A over D, which is going to be equal to 8.854 times 10 to the negative 12. And we'll go ahead and put that in parentheses. And then that's going to be times 0.0144. Okay, so we do that. And then we're just going to go ahead and put D, which is 4.5 times 10 to the 3. Okay, then we're going to use that value to actually get the answer for C. This is really just the first part for C. So then that's going to be equal to approximately 2.83 times 10 to the 11. Okay, so now that that is all said and done, now we're going to go ahead and continue with E. So since we've calculated for the capacitance, not taking into account the plexiglass, then now we can, this CE value has effectively changed, right? So that's why we had to do this in the first place. So now that we're able to do that, we can just go E is equal to 1/2 times the new CE. Excuse me, let me just go ahead and delete that very quick. That's going to be 1/2 times 2.8 times 10 to the negative 11. And our volts are still remaining the same. Let's go ahead and do this really quick. Oh, excuse me. Let me just go ahead and delete that. Okay, there you go. All right, so you multiply all of that together, and then you're going to get 4.59 times 10 to the 9. Mind you, most to all of the values here are sort of rounded just for simplicity's sake, just because of the nature of this presentation. It would take me a long time if I wrote out every single exact number. But I know these are correct because when I did the problem earlier, like with my calculator is able to take whole numbers, the numbers were very similar, if not the exact same. So yeah, so that is the end of my presentation. That's going to be it for problem 24.64. And thank you. Thank you so much.